This is Mrs. Roman, and we are going to do the notes 8.10a, convection, ocean currents, and wind together on this video, and then you're going to complete the surface current worksheet. So follow along, complete these notes, and then do the worksheet. So first we're going to talk about the transfer of the sun's energy. So think back to 7th and 6th grade. The sun has energy, and that sun is transferred to the earth in different forms. So the first one we're going to talk about is radiation. Radiation is the transfer of energy as waves. Earth receives its energy from the sun. The sun's energy travels to the earth in the form of radiation. So an image that represents radiation would be my sun and waves coming down on my hot concrete. If you've ever stepped onto the pavement during the summer, you would have felt the result of radiation, the sun heating up the pavement. So the second way the sun's energy is transferred is through conduction. So conduction is the transfer of thermal energy from one material to another by direct contact. So that concrete was heated up through radiation, and then you stepping on it and feeling it, that's conduction. So if you've ever grabbed a hot pot on a stove, and you put your hand on it, that's my hand, that hot pan, when you touched it, is conduction. Lastly, we have convection. And this is what we saw yesterday in the little lab. So convection is the transfer of thermal energy by the movement of a liquid or a gas. So this occurs in both liquids and gases. So convection works when a liquid or gas is unevenly heated. Hot liquids or gases are less dense. Again, we saw this yesterday. They are less dense and they rise, causing convection currents. The warmer sections of the material will rise, while the cooler parts sink. So we know this from seeing the red hot water rises, and the blue water sank yesterday. So here's an image to represent what we saw yesterday. The warm air is rising, and the cool air is sinking. Remember, convection is for both gas and liquid. So our image here, we want to draw warm rising or hot and cold sinking. Warm is less dense, cold is more dense. Alright, now let's look at the results of convection. What happens because of convection in the atmosphere? So why air moves. So we just said warm air is less dense.
I need Ayana
And
Smith-White to please report to the main office. Ayana Smith-White, please report to the main office. Your party is waiting.
so sorry for that. Warm air is less dense and rises, while cool air is denser and sinks, which we just talked about, just like the liquid we saw in our lab. When the warm air rises and the cold air sinks, we have what we called convection currents. Okay, just like we saw up here, this is a convection current. Now these cause winds. So winds is the moving of air and is created in differences in air pressure. So the differences in air pressure are caused by the uneven or unequal heating of the Earth. Okay? So some parts are heated more, some parts are heated less, uneven. The greater the difference in the air pressure, the faster the wind moves. So if you've ever been outside and the wind is blowing really, really hard, we have a big difference between our air pressures. And when maybe there's no wind, we have very little air pressure difference. There are two types of winds. We have global winds and we have local winds. Both types of winds are caused by that uneven heating of the Earth's surface and by pressure differences. So you don't need to know the type of global winds or the type of local winds. All you need to know is that both winds are caused by uneven heating and pressure differences. Those are the two things working together to cause winds in our atmosphere. Uneven heating and pressure differences. Very important there. DCA question. Okay? So turn your page and we're going to talk about the Coriolis effect. So the Coriolis effect is the movement of wind is affected by the rotation of the Earth. Okay? So remember from last unit, the Earth rotates on its axis. And this causes what we call the Coriolis effect. All right? So because of this, winds do not blow directly from north to south. The Coriolis effect causes the winds to change directions. Because of the Coriolis effect, winds in the northern hemisphere curve to the right, and winds in the southern hemisphere curve to the left. Right? So if we have our Earth up here on its axis, and here's our equator, we're going to curve to the right in the northern hemisphere and to the left in the southern hemisphere. Okay, that's the Coriolis effect. Right in the northern hemisphere, left in the southern hemisphere. Okay. Let's talk about ocean currents now. Now, ocean currents is where your worksheet's going to come in. So we're going to talk about ocean currents, and this is what's going to be talked about on your worksheet that you're going to do. So the sun also provides the energy that drives convection in the ocean and produces ocean currents. Okay? The sun provides all the energy. The sun provides all the energy. And there are two main types of ocean currents: surface currents and deep currents. Right. Obviously, surface currents are on the surface of the water, and deep currents are farther into the water. Surface and deep currents interact and trade places. So if we see this image here, our surface currents carry warm, less dense water from the equator to the poles. So we're going from the equator to the poles. Warm water from the surface currents replaces the colder, denser air and sinks to the ocean floor. So we're sinking. Deep ocean currents carry colder, denser water along the ocean floor, from the poles to the equator. Water from the deep currents rise to replace the warm water. So we're still having this convection currents. So even in the ocean, these currents are happening. Our surface currents are moving from the equator to the poles. Our deep currents are moving from the poles to the equator. So let's talk about warm ocean currents. Warm ocean currents originate near the equator. And remember, the equator is that imaginary line on the globe, the equator. And it moves towards the poles or higher altitude. Okay? Warmer the air, so warm ocean currents warm the air. That makes sense, right? If they're warmer, they're going to warm the air. And they bring warmer temperatures to land. So because they're warm, they bring warmer temperatures to land. Cold ocean currents originate near the poles or higher altitudes. Okay? So these happen near the north and the south poles. Oops, that says, I meant south. I put a P because I said poles. And they move towards the tropics or lower altitudes. Colder ocean currents can decrease air temperature and bring cooler temperatures to the land. So again, here we're going from the equator to the poles. And here we're going from the poles to the equator. And I have an image to show you that here. So our warmer currents are starting at the equator and going to the poles. Starting at the equator and going towards the poles. All of these are starting at the equator and going towards the poles. Our cold currents are starting at the poles and moving towards the equator. Right. This one's taking a long time, but it is still moving slightly up. Okay, same thing here. A long time, but it does start to move up. So cold currents start at the poles and come towards the equator. Warm currents start at the equator and go towards the poles. So let's look at these last three questions. Take a minute, pause the video, and read through these questions and try to answer them. Okay? These three questions, but they're double, triple starred. It's because these are the three things that you need to take away from these notes. They are the three things that will be on the DCA from these notes. So pause the video, take a second to answer them, then check your work. Okay, I hope you paused, and I hope you thought about these questions on your own. So let's go through them. What provides the energy that drives convection currents in the atmosphere? If you go back to the beginning of your notes, and actually multiple times in your notes, it says the sun. The sun provides the energy. Second question, what causes wind in the Earth's atmosphere? So if we go back to our wind notes, we start that. Uneven heating of the Earth's surface and pressure differences. So uneven heating surface and pressure differences. Last question. How can ocean currents affect air temperature along the coast? All right. So that would be back up here. Warm currents can warm temperatures. Cold currents can cool temperatures. So that is all of the notes. These are very important. We will be referencing these a lot. Please make sure that you've completed them. All right? Next step. The instructions to this activity are posted on Google Classroom right underneath this video. So turn to the surface current webpage, surface current page, and it has instructions. These are numbered. It tells you what color to color each number. It then tells you not to color the oceans, right? Draw the equator. Follow the instructions on what you're supposed to do. Then you have 5 questions to answer. Read carefully and answer the 5 questions. Okay, there is a back. If you've done the notes, you can find most of the answers in your notes. Right? If you have a question about this, let me know. But you should be able to answer all these questions. Okay? Those are the 2 assignments. They both are grades for this. Make sure you complete both. You should have plenty of time to complete both when you are finished, and only if you're finished with both the notes and this surface current activity, then you may work on your homework. If you're finished with all 3 of those things, you may work on something else. Thank you guys, and I will see you the next class period.